Hi there. So our next two sections will focus on quadratic equations, functions, zeros, and models. While in this section we're mainly focused on quadratic functions and finding their zeros and a little bit more associated with that. It will be the next section where we focus heavily on the applications of these quadratics. But I thought what I would do over here at the top is just provide you a little bit of a foreshadowing, just so you would have I guess a little bit of a taste of what's to come. So a couple of examples here of quadratic functions modeling in real life. If you think about the first graph that I've drawn over here, think about a company. They have a production cost. If they're producing whatever they might be producing, whether they're producing flashlights, batteries, or I don't know, they produce clothing, boots, whatever it is that they're producing, there's an overhead cost, okay? Think about it. The company has an overall goal that they want to minimize their cost, maximize their profit. So that's the idea here with it. I have on in the graph over here on the left that the number of items produced is along the x-axis. Their production cost associated with those number of items being produced is along the y-axis, and so their goal is to reach this sweet spot here, that minimum. So where they're minimizing their cost, okay, in relation to their profit. And then the other example I actually did, profit related to the price of an item. So I've got the price of an item labeled here along the x-axis. Most companies want to strive to gain their maximum profit that they can. I mean, you think about it. If you go to the store, if something, I know, like if I'm just sitting here comparing two items and something is ridiculously cheaper than the other, I start to question, why is it that way? And sometimes I'll go with it, but other times I'm thinking, maybe I shouldn't. On the other hand, there gets to be a point where the price is too expensive and people just tap out and say, nope, that's out of my price range, okay? So again, they're trying to reach that sweet price that they can reach their maximum profit, okay? So those will be things that we talk about in the next section. All right, so moving on then to their focus for this particular set of notes, we'll be looking at quadratic equations, and of course quadratic equations are of the form ax squared plus bx plus c. A, b, and c are all real numbers. A cannot equal 0, okay? They will have two solutions, and there are three ways to solve a quadratic equation. If you can factor, I always recommend factor, set those factors, any factor that has a variable in it, set those equal to 0 and solve for your variable, okay? That's always my go-to top method. I always say do that first. Square root principle. If you just have a simple x squared equals some number, then the easiest way to do that would be then to just take the square root of both sides. And so x equals then plus or minus the square root of k. So those are two very straightforward. Quadratic formula. If you aren't able to factor it, you can't use the square root principle, then we got to go to the quadratic formula. It should be noted, sometimes folks, they say, well, I don't like to factor. Can I just use the quadratic formula? Absolutely, you can. Quadratic formula works for any quadratic, okay? You need to know this formula though. X equals negative b plus or minus square root b squared minus 4ac all over 2a, okay? All right, so I've got these notes designed where I'll do one, then let you try the next one. So with that said then, I'm going to move on down here to example 1, and I want to find the zeros for this function. So we'll look at doing number 1 here together. So in number 1, it wants us to find the zeros. So again, I try to say, okay, well, can I factor this? So since it's a leading term of 1, I immediately try to go to guess and check. Only way to multiply to give you x squared. X times x. Now we think about ways to multiply to give me 30. So like 5 times 6 is in common, but 5 and 6 couldn't give me a 7. 10 times 3 is another way. That would work. 10 times 3 would give me 30. I want a negative 7x. So just like we were doing in that factoring preview, if you are struggling with factoring, go back and watch that factoring preview that I posted in Blackboard. Outside I've got 3x. Inside is 10x, because you're going to really see me go to town on factoring in this particular video. My middle term here is a negative 7. So in order to get the negative 7, I'm going to have to make that 10 negative. So minus on the 10, 3 is positive, okay? now it says set, the directions above said set any term that had an x with it equal to 0 and solve for x. So I set x minus 10 equal to 0 and x plus 3 equal to 0, and I solve for x. So here, this is a quick solve. Just add 10 to both sides. X equals 10, subtract 3, x equals negative 3. Those are our two solutions. Final answer. Okay? Just remember, every time we were finding the zeros before, when we found the zeros, we set our function equal to 0 and solve for x. So setting our function equal to 0 here, though, and solving for x is going to require that we factor. If we can. If we can't factor, then I would recommend now that you pause the video and try number 2. Then I'm going to come on down here to number 3. And in number 3, oh, I just noticed in number 2, one small thing. You'll notice here in number 2 that at the very beginning, it's not equal to 0. Your first step you'd need to do is subtract that 16, get it equal to 0. So you would have x squared plus 6x minus 16 equals 0. Now you're ready to guess and check. Okay? All right. I didn't realize that one had a little bit different component, but I know you can go from there. All right, and check yourself with the solution key. Now I'm going to come on down here to number 3. This can be factored, just so you're aware of that. But I could also, since I just have one variable here, I could also just go through the motions of solving for this variable. So in order to do that, my goal then would be to try to get this x all by itself. So I'm going to take that 36 to the other side by doing the opposite. So I add 36. 3x squared equals 36. Get closer and closer to getting that x all by itself. So divide by 3. Cancels out. So x squared equals, what's that, 12? Take the square root. X equals, that'd be plus or minus. Now think about this, 12, that can be reduced. Remember our reducing radicals. Highest number in our list that will divide evenly into 12, 4 times 3. So that gives me plus or minus 2 square root of 3. 2 square root of 3. And then that would be our final answer. If you want to get the approximate answer, all you have to do in your calculator is say 2 times the square root of 3. You should be getting approximate solutions of plus or minus 3.46. Okay, so I'm going to box that in. I'm just giving you this is called the plus or minus 2 square root of 3 is the exact answer. This is the approximate answer. Because as we move forward in our applications in the next section, if we were measuring feet here, 2 square root of 3 feet doesn't mean much to us, but 3.46 feet does. Okay. All right, let's look at number 5. In number 5, first thing I need to do is I need to get this equal to 0, so I add 2x, because I'm trying to find the zeros, so I add 2x. 5x squared plus 2x plus 2 equals 0. Then from here, I try to factor if I can. So think about my guess and check. The only way to multiply to give me 5x squared, 5x times x. The only way to multiply to give me 2. 2 times 1. So now let's look. On the outside I have 5x. On the inside I have 2x. My goal, I'm trying to get a 2. Well, 5 plus 2 is 7. 5 minus 2 is 3. So that's not going to work. Let me swap my 2 and 1. So if I put the 1 in the front and 2 in the back, it gets worse, doesn't it? Outside, 5 times 2 gives me 10x. Inside, 1 times x gives me 1x. 10 and 1, there's no way I'm going to be able to get a 2 out of that. So what that means then is this problem cannot be factored. So, since it can't be factored, then that forces me to use quadratic formula. And so your quadratic formula, I'm going to write it down here again. Negative b plus or minus square root b squared minus 4ac all over 2a. And then I'm going to come here to the problem itself, and I'm going to denote, here's my a, here's my b, and here's my c. Now this negative b here at the front, usually whenever I do these problems, I always say, instead of negative b, I say opposite b. So because my original b here is 2, and since I want it to be the negative of my b, I want it to be opposite b. So the opposite of positive 2 would be negative 2. It helps clear up the fact that a lot of times if this were a minus sign here, folks get confused in terms of, oh, well, there's a negative already there. But so if this were a minus sign here, I'd want the opposite of negative 2, so I'd put in a positive 2. So I think of this negative b here as opposite b. Plus or minus square root b squared, so 2 squared, minus 4 times a, which is 5, and c is another 2, all over 2 times a, so 2 times 5. All right, let's start cleaning up. So I have negative 2 plus or minus square root. 2 squared, of course, gives me 4. Minus 4 times 5 is 20. 20 times 2 is 40. All over 10. Start cleaning up. Negative 2 plus or minus the square root of negative 36. All over 10. We'll go again. Square root of negative 36 like we did in a previous section. We know the square root of 36 is 6, and because it's a negative, it's going to be 6i. So I have negative 2 plus or minus 6i all over 10. 2, 6, and 10 all have a number in common, so I'm going to reduce that. I'm going to divide them all by 2. So think about here, I'm going to get a different color. 2 divided by 2 would give you 1. 6 divided by 2, 10 divided by 2. So I have negative 1 plus or minus 3i all over 5. And of course, you can write this as negative 1/5 plus or minus 3/5 I. Either one is acceptable. And most likely my lab math wants this latter answer here. Okay? All right, I encourage you, pause the video, you try number 6. And I'm going to flip it on over. Looking at number 7. First thing I want to do is get it equal to 0. I'm still trying to find my zeros here. So I'm going to pull that 6 over. So I have, change my color, 10x squared minus 16x, and I'm pulling that 6 over, so I'll be adding 6 to both sides, so plus 6 equals 0. Now from here, look at all three of those terms. They're all even, so I know I can pull a 2 out of them. So let's do that. That would leave me with 5x squared minus 2 times 8, give me 16, plus 3 equals 0. All right, so now I try to guess and check from here. The only way to multiply to give you 5x squared, 5x times x. The only way to multiply to give you 3, 1 times 3. Now think about it. If you put that 3 in the back, then you're going to have multiply 3 times 5 here, which will give you 15. So you're getting really far away from that 8. Let's put the 3 in the front. 3 in the front, 1 in the back. So now on the outside I have 5x. Inside I have 3x. My goal, middle term, negative 8x. And I can get negative 8x out of 5 and 3. I would need to make them both negative. So minus, minus. Now remember, you set all the terms that have letters with them, variables, equal to 0. So I don't need to set 2 equal to 0. I need to set 5x minus 3 equal to 0 and x minus 1 equal to 0. Okay? And so now I go through and I solve. So I had 3. 5x equals 3. Divide by 5. So x equals 3/5. That's one answer. And come over here. That's a simple solve. Just add 1. So x equals positive 1. So we've got 2 answers, a positive 1 and a 3/5. Okay. So again, if you pull out a common factor, if it doesn't have a letter with it, you don't need to set it equal to 0. Number 8, when you get this one all on the same side, so this 3x cubed here, that's your leading term, I'd keep it positive. And I'd pull the 5x squared and the 2x over. Whatever you do to one side, do to the other. So you're going to subtract 5x squared and add 2x over here. So that I have now 3x cubed minus 5x squared plus 2x equal to 0. All three of those terms have an x in common. You're going to factor that x out. Then you're going to guess and check with that, or use the bottoms up method that I showed you in the factoring video. Use that method, whichever works for you. But then once you get it factored, you're going to have 1, 2, 3 terms that are going to be set equal to 0. Okay, so you'll end up with 3 solutions on that one. I'm going to let you go from there. All right, I'm going to scoot on down here to number 9. I'll do that one with you. In number 9, don't let the x to the 4th here trip you up. Okay, so x to the 4th, and then you've got, so it's in descending order, x to the 4th, x squared, no x's. I don't have a common factor. So let's go to our guess and check. What's the only way to multiply to give you, well, most common way to multiply to give you x to the 4th? I'd probably try with, here's the best way to think about that. You need to try x squared and x squared because your middle term is an x squared. You wouldn't want to do x cubed and x. You need to get an x squared in the center. So you need x squared and x squared. So when you multiply that, that's going to give you x to the fourth. Now think about a way to multiply to give you 50. You got 2 times 25, 1 times 50, and 5 times 10. 5 times 10 would work for us. Because we are trying to get a negative 5 in the center, we would need to make, which one? Negative. Hopefully you agree that 10 would need to be negative. So now we would set x squared plus 5 equal to 0 and solve for x, and x squared minus 10 equal to 0 and solve for x. So we come over here, so just subtract 5. X squared equals negative 5. Take the square root. X equals, now remember that negative 5 there, you can have a plus or minus. You could rewrite that as the same as negative 1 times 5, still underneath the square root. We know the square root of negative 1, that's your I, right? So you have plus or minus then the square root of 5, and then we'll put the I behind it. So there's 2 of your answers. Come over here and solve for x. I'll add 10. X squared equals 10. Take the square root of both sides. X equals, can't break that down any further, so my final answer then would be plus or minus the square root of 10. Notice how this was, to this polynomial here, quadratic, was raised to the 4th power. So polynomial here, so it was raised to the 4th power. So since it's raised to the 4th power, I have 1, 2, 3, 4 solutions. Look back at the previous one we did together. This is raised to the 2nd power. We had 1, 2 solutions. Hopefully you've already tried number 8. And look at the leading term here. It's raised to the 3rd power, and we ended up with 1, 2, 3 solutions. That's a loose check for yourself, at least for right now. We'll have some multiplicity coming in later on, but at least for right now, you should be kind of thinking along those terms in terms of getting your final answers, making sure you've got enough final answers. Okay. There's a little bit more to that, but at least for right now, like this is raised to the 4th power, so I should be aiming to get right at or close to 4 answers. Okay. In number 10, I thought I'd run through this one with you too, just because it's slightly different. It's not too bad, but it is slightly different. So your goal is to solve for x. It's written a little differently here, but what I would do is I would just try to get closer and closer to getting this x all by itself. So to do that, I'd add 18. And I think to do that this way because I only have one x versus the other problems that we looked at here had multiple x's in it. So I add 18 to both sides, cancels out, so I have 2 parentheses, x minus 3 squared equals 18. Then I'm going to divide by 2. So then I have x minus 3 squared equals 9. Now I want to get closer and closer to getting this x all by itself, so I got to get rid of the squared. So I'm going to take the square root. The square root of something squared is just itself, so x minus 3 equals square root of 9 plus or minus 3. Next step, get this x all by itself, so add 3 to both sides. So x then equals 3 plus or minus 3. So essentially you've got 2 solutions, and you can go ahead and find those out. So we know that one answer is 3 plus 3, and the other answer is 3 minus 3. So 3 plus 3, of course, is 6. 3 minus 3 is 0. Those would be your 2 answers, 6 and 0. Okay. Just below that is referred to as your discriminant. And the discriminant is just kind of like a means, a way to kind of check yourself in terms of how many solutions should you expect. And remember, so the discriminant is related to the part that is underneath the square root. The discriminant is just taking apart part of that quadratic formula for you, b squared minus 4ac. Remember, this is the part under the square root. And if you remember that that's what b squared minus 4ac is, then that helps me remember the solutions down here. Because it's the first situation is saying if that b squared minus 4ac is greater than 0, meaning it's positive. So if it's positive, then there's 2 real solutions. Because think about it, you can take the square root of a positive number. If it equals 0, you're only going to have 1 real solution. And if your b squared minus 4ac is less than 0, meaning it's negative, so think about it, if you've got something underneath the square root and it's negative, you're going to have 2 complex solutions like we talked about in the last section. They're imaginary solutions. So hopefully that helps you kind of keep those straight. Let's do number 11 here together. It says describe, that's what typically what they'll say here, describe the nature of the solutions. They're not looking for you to find them. They're just looking for you to say, are there 2 real, 1 real, or 2 imaginary, okay? So I just need to find b squared minus 4ac. So remember, this is my a, my b, and my c. So b squared, so negative 1 squared minus 4 times a times c. Negative 1 squared, of course, is positive 1. Minus 4 times 6 is 24. 24 times 10, 240. Then 1 minus 240 will give you a negative 239. So since it's a negative, that is telling me that what is essentially, if I had worked through the quadratic formula, is telling me that what's underneath the square root would be negative, then that means I'm going to have 2 imaginary solutions. Or complex, same thing, okay? And let's wrap it up here with number 13. Just a little bit of a foreshadowing of some applications. All right, so here in number 13, it says find the dimensions of a rug that has an area of 48 square feet. So the area is 48 square feet and a perimeter of 28 feet. Perimeter is 28 feet. Let's think about, we didn't specify here that this was a rectangular rug, but that's what I had in my mind and I didn't write it. So it's a rectangular rug, just an FYI. And so let's generate then the formulas for area and perimeter of a rectangle. So area of a rectangle, length times width. Perimeter of a rectangle, 2 times your length plus 2 times your width, just adding up all your sides. Now, we know in the area formula, we already know the area is 48, length times width. Over here in the perimeter formula, we know that the perimeter is 28. What needs to happen is we need to come to this over here to this perimeter formula, and I need to solve it for either L or W. It doesn't matter which one we solve for, but I need to solve it for L or W. And once I solve it for L or W, I'm going to be able to substitute it in over here into the area formula so that I have one equation with one unknown. So, yes, because right now I've got one equation with 2 unknowns. I don't know the length and the width. All right, so I'm just going to take the perimeter formula over here, and I'm going to solve it for L. So if I was going to solve it for L, then I would take 2W to the other side, subtract 2W. So I have 28 minus 2W equals 2L. And then I'm going to divide by 2. And you just divide every term by 2. So then that cancels out there. And so my length then equals 28 divided by 2, of course, 14. 2 divided by 2 just gives me W. So I have 14 minus W for my length. Now, as I mentioned, now come over here to your area formula, and in place of L, plug in that 14 minus W. And then you've got your width. So this is length times width. We just replaced the length with what we solved it to be. Now, we want to solve for W. But this is nice because now this formula over here is all in terms of W. Okay, so now I can distribute. 14 times W, 14W, W times negative W, negative W squared. I've got my 48. Now, we're trying to figure out what my W is. I'm trying to solve for W. In order to do that, I need to get this function equal to 0. Now, it would be a one step if I just brought the 48 over. However, I typically don't like to work with my leading term, my W squared there, to be negative. So I'm actually going to take W squared and 14W to the other side, to join the 48. So I'm going to add W squared and subtract 14W. Add W squared and subtract 14W. So that way over here it cancels out. I'm equal to 0. Write this in descending order, so I have W squared minus 14W plus 48. And then I now go to guess and check. The only way to multiply to give me W squared. W times W. Think about ways to multiply to give you 48. That when you add or subtract will give you 14. Really, you know, probably the key to factoring is being really good with your multiplication tables. And if you're not good with your multiplication tables, practice, 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 okay? But common way to multiply to give you 48, 6 times 8. Outside's 8W for me. Inside is 6W. I want a negative 14W on the inside, and I can get that. I'd need to make them both negative. and now set both of those equal to 0. So if I set this one equal to 0 and solve for W, I would have a width equal to 6, and everything's measured in feet, so that'd be 6 feet. If I solve this one for W, then my W would be equal to 8 feet. Okay. So essentially you've got two options, and length and width are basically relative, but I'll write it here nonetheless, that if we define that our width is 6 feet, so if we say that our width is 6 feet, then to find our length would be equal to plugging it into this formula, 14 minus our width, so 14 minus 6, our length then would be 8 feet. Or if you started out and you said, okay, well my width is 8 feet, then to find my length is going to be 14 minus 8, which is 6 feet. Essentially, this rug is 6 by 8, okay, or 8 by 6. It's the same thing, okay? So I just don't want you to get hung up in that, okay, in that regards. But there are other problems though that the difference here matters, okay? So I want to go ahead and show both of those. All right, let me know if you need anything. Thanks a lot. Bye.